Now today we are going to see the general solution. The solutions of a trigonometric equations which are generalized by using its periodicity are called its general solutions. In part 1 we see the definition of periodicity, that is periodic function. For example, for the equation sin x equals to root 3 by 2, we know that at angle x is equals to pi by 3, that means at angle 30 degree we get the sin x equals to root 3 by 2. Also in part 2 we construct a chart up to 360 angle, so from that we also check for the angle here 2 pi by 3 we get sin x equals to root 3 by 2. Again at 7 pi by 3 we get sin x equals to root 3 by 2. That means at angle x equals to pi by 3, at angle x equals to 2 pi by 3, at angle x is equals to 7 pi by 3 are its general solution, because we getting the value at x equals to pi by 3, 2 pi by 3, 7 pi by 3, sin x equals to root 3 by 2. Clearly, the general solution is always infinite in number. In first principle, we see that we get only two values, that is 0 or greater than 0 and which must be less than 360. So, in general solution, we get infinite number of values. Note, for general solution of any trigonometric equation, we will use n as an integer, that is n belongs to z. Now we see the proof of first theorem, that is the general solution of sin theta equals to 0 is theta equals to n pi, n belongs to z. So for that we know that for angle 0 we get sin 0 0, for angle pi we get sin pi 0. So from this condition we write here theta 0 less or equals to theta strictly less than 2 pi. Now from this we conclude that for angle theta equals to 0 we get sin theta equals to 0, for theta equals to pi we get sin theta equals to 0. That means these are the two solutions. Now by periodicity of trigonometric functions, which we discussed already, we see the formula 360 minus theta, 360 plus theta, that is 2 pi plus theta, 2 pi minus theta. If one round is completed, then we write 2 pi. If 2 round is completed, we write 2 into 2 pi. If 3 round is completed, round means cycle. If here third round is completed, we get 3 times 2 pi. In this way, we repeat. If it's n times, then we write it as n into 2 pi, that is twice n pi. That means after completing the one cycle, we get the same value, that is we write here for the trigonometric formula sin 2 pi twice n pi plus theta is equal to, this value is in first quadrant. We know that all values in first quadrant are positive, so we write sin twice n pi plus theta is equal to sin theta. Now in this formula we have to substitute the value of theta as 0 and theta as pi. From this we get the general solution. Now first we substitute theta equals to 0, when theta is equals to 0, sin twice n pi plus 0 is equals to sin 0. Therefore sin twice n pi is equals to sin 0. Denote this as equation number 1. Now see the second. When theta is equals to pi, when theta is equals to pi, now substitute the value of theta as pi in this formula. Therefore sin twice n pi plus pi is equals to sin pi. Now after adding this, taking pi common, we get pi in bracket twice n plus 1 is equals to sin pi. We note this as equation number second. Now see from first equation, sin twice n pi equals to sin 0. That means for angle theta equals to twice n pi, sin 0 is 0. So we get the value 0 for the angle twice n pi equals to 0. That means theta equals to twice n pi. Now here n belongs to z. So if we take n is equals to 0, then we get theta equals to 0. When we take n equals to 1, we get theta is equals to 2 into 1 into pi, that is equals to 2 pi. When we take n equals to minus 1, theta is equals to 2 into minus 1 into pi is equals to minus twice pi. Similarly, you can check for 2, 3, 4, 5. So likewise we get the values. Which type of value we get? Theta equals to 0, plus or minus. We write here plus or minus 2 pi. When you substitute the value of n is equals to 2 plus 2, we get 2 into 2 4. So we get plus 4y. When you substitute n is equals to minus 2, then 2 into 2 4, and for n equals to minus 2 we get minus, so we write here minus. In this way we write plus or minus 6 pi and so on. That means here we getting the value in the form of 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, that is 360 degree rotation values. Now from equation second, what we conclude? Here we get theta equals to, from equation second, theta is equals to twice n plus 1 into pi. Now again when n is equals to 0, we have to write here n belongs to z. Z is set of integer. When n is equals to 0, when n equals to 0, this first term get 0, 0 plus 1 is 1, so we get the value pi. Theta is equals to pi. When n is equals to 1, when n equals to 1, we get here 2 into 1 is 2, 2 plus 1 3, so 3 pi. Theta is equals to 3 pi. When we substitute n is equals to 2, that is 2 into 2 is 4, 4 plus 1 is 5, so n is equals to 2, we get theta is equals to 5 pi. In the same way, when we replace n is equals to minus 1, n is equals to minus 1, we get theta is equals to, if we replace n equals to minus 1, 2 into minus 1 is minus 2, minus 2 plus 1, that is minus 1, so we get here value minus 1 into pi, that is minus pi. When we substitute n is equals to minus 2, so 2 into minus 2, which is minus 4, minus 4 plus 1, that is minus 3, so we get theta is equals to minus 3 pi. When n is equals to minus 3, n is equals to minus 3, that is minus 3 into 2 is minus 6 plus 1, that is minus 5, so we get theta is equals to minus 5 pi. Now observe the terms, remaining terms you can observe from this. N equals to minus 4, use minus 7 pi. N is equals to minus 5, use you next value. Likewise you can calculate the next values. Now we see here theta is equal to, if we rearrange combining these two values, for theta equals to 0 and for theta equals to pi. Now see the theta's result. Theta is equal to, first we write the value 0. So we write here 0. Then see these two values, plus pi, minus pi. So from this we write plus or minus pi. Now see the next value, plus or minus 2 pi. Plus or minus 2 pi. Then observe the next value, plus 3 pi minus 3 pi. From this we write plus or minus 3 pi. Then next value, plus or minus 4 pi. Plus or minus 4 pi. What will be the next value? Plus 5y minus 5y. That means plus or minus 5y, and so on. Plus or minus 6y, plus or minus 7 5y. That means these values are in the form theta is equal to n pi, n belongs to z. That means when we replace n equals to 1, when n equals to 0, we have to start from 0 because n is set of integer. So when n equals to 0, we get theta equals to 0. When n equals to 1, we get theta equals to pi. When n equals to 2, we get theta equals to 2 pi. When n equals to minus 1, we get theta equals to minus pi. That means this theta equals to n pi is the general solution. That means when we substitute any value belonging to set of integer, we get the solution. Therefore, sin theta equals to 0 has a solution theta equals to n pi, n belongs to z. So in this way you can calculate you can write the proof for general solutions. For cos theta equals to 0, tan theta equals to 0. See the next theorem. Cos theta equals to 0 is theta equals to twice n plus 1 into pi by 2, n belongs to z. So first we find two values for which cos theta equals to 0. When theta is equals to pi by 2, that means for cos pi by 2, that is cos 90 is 0. So first angle is theta equals to pi by 2. Then second angle for theta is equals to 3 pi by 2, that is for theta is equals to 270 degree, we get cos 270 equals to 0. Therefore we write 0 less or equals to theta strictly less than 2 pi. Now by periodicity of cos x, so we have to write the formula cos 2 pi plus theta. So instead of 2 pi plus theta, we write here periodic form for n cycle. So we have to write twice n pi plus theta formula that we already used in previous theorem. So cos twice n pi plus theta is equals to cos theta. From that we write cos pi by 2 is equals to cos twice n pi plus pi by 2, and for same use the angle theta equals to 3 by 2. So instead of this pi by 2 we write 3 pi by 2. Instead of pi by 2 we write 3 pi by 2. That means here we use the formula cos twice n pi plus theta equals to cos theta. From that we write these two conditions. Now from this we write here theta equals to twice n pi plus pi by 2 and theta equals to twice n pi plus 3 pi by 2. Thus cos theta equals to 0 for theta equals to twice n pi plus pi by 2, or theta equals to this twice n pi plus 3 pi by 2, n belongs to z. Therefore cos theta equals to 0 for theta equals to 4n plus 1 into pi by 2, or theta is equals to 4n plus 3 pi by 2, n belongs to z. For our convenience we cross multiply this first. After cross multiplying we get 2 into 2 4, that is 4 pi plus pi upon 2. So taking pi by 2 common, 4n plus 1 into pi by 2, or you can easily observe here base is 2, so making base 2 multiply by 2 and divide by 2, so 2 into 2 4. So after taking pi by 2 common, we write this as 4n plus 1 into pi by 2. We have to use the same procedure here. After multiplying and dividing by 2, and taking pi by 2 common, we can write this term as 4n plus 3 into pi by 2. Now for this first condition, when we substitute n equals to 0, that means this term 0, 0 plus 1 is 1, 1 into pi by 2, so we get pi by 2. When n is equals to plus 1, so we write here 4 into 1 is 1, sorry, 4 into 1 is 4, 4 plus 1 5, so we get 5 into pi by 2, that is 5 pi by 2. When n is equals to plus 2, so 2 into 4 is 8, 8 plus 1 9, that is 9 pi by 2. That is, the values are pi by 2, 5 pi by 2, 9 pi by 2. Then next value is 11 pi by 2 for n is equals to 1, 2, 3, 4 and so on. When we substitute n is equals to minus 1, when n equals to minus 1, that is 4 into minus 1, that is minus 4 plus 1, that is minus 3. So we get minus 3 pi by 2. Next value we get minus 7 pi by 2. Next value we get minus 11 pi by 2 after substituting n equals to minus 2, n equals to minus 3 and so on. Now observe for this second formula, when we substitute n equals to 0, when we substitute n equals to 0, that means this term gets 0, that is next is 0 plus 3, 3 into pi by 2, we get 3 pi by 2. When we substitute n is equals to 1, so when we substitute n equals to 1, 4 into 1 is 4, 4 plus 3, 7, 7 pi by 2, so we write here 7 pi by 2. Likewise, after substituting, we get the values 11 pi by 2. When we substitute minus value, we get, when n equals to minus 1, 4 into minus 1, that is minus 4 plus 3, that is minus 1. So minus 1 into pi by 2, that we get minus pi by 2, minus pi by 2, minus 5 pi by 2, and for next value, likewise we get the result. Now what is the conclusion from this? Now observe the terms. Here first value we get pi by 2, then next value 3 pi by 2, next value 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2. That means these values are the odd multiple of pi by 2, that is in the form of twice n plus 1. So for odd we write twice n plus 1, for even we write twice n. So after rearranging the terms from these two, pi by 2, 5 pi by 2, 9 pi by 2, plus terms, here plus term 3 pi by 2, 7 pi by 2, 11 pi by 2, then negative terms minus 3 pi by 2, minus 7 pi by 2, minus pi by 2, minus 5 by 2, minus 7 pi by 2. From this we write cos theta equals to 0 for plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 by 2. Then what will be the next value? Plus or minus 7 pi by 2. So from this we write cos theta equals to 0 for theta equals to twice n plus 1 into pi by 2, n belongs to z. Hence the general solution of cos theta equals to 0 is theta is equals to twice n plus 1 pi by 2, n belongs to z. Or you can substitute the values that we see in first theorem also, we get the result. Now see the next proof. For tan theta equals to 0, theta equals to n pi is the general solution. So using the condition for tan theta equals to sin theta upon cos theta, or by using the formula, we can give the proof for tan theta equals to 0. We have tan theta equals to sin theta upon cos theta, where cos theta not equals to 0. Cos theta in denominator, so theta not equal to 0, because any number upon 0 is not defined. So we have to write this condition first, cos theta not equal to 0. Then second possibility, tan theta equals to 0 when sin theta equals to 0. Therefore when sin theta equals to 0, we get tan theta equals to 0, because 0 upon any number is 0. Hence the general solution of tan theta equals to 0 is same as that of sin theta equals to 0. So we know that for sin theta equals to 0, general solution is theta equals to n pi. Hence the general solution of tan theta equals to 0 is theta equals to n pi, n belongs to z. In this way we see the general solutions for sin theta equals to 0, cos theta equals to 0 and tan theta equals to 0. Now by using the properties you can write general solutions for remaining, that is for cot, sec and cosec. Now we see in note for which solution exists or not. So note down. First, cot theta equals to 0. When cos theta equals to 0, the general solution of cot theta equals to 0 is theta equals to twice n plus 1 pi by 2, n belongs to z. That means you can write proof as we write for tan theta equals to sin theta upon cos theta. There cos theta not equals to 0. Here we do not have sin theta equals to 0. So the cos theta must be 0 here. So the general solution for cos theta is the general solution for cot theta. Now see, for sec theta equals to 0, whether the solution exists or not. Since sec 0 less or equals to minus 1 or sec 0 greater or equals to 1, the equation sec 0 equals to 0 does not have a solution. So you must remember, for sec 0 equals to 0, we do not get a general solution. Now see for cosec. Since cosec theta less or equals to minus 1 or cosec theta greater or equals to 1, the equation sec theta equals to 0 does not have a solution. That means we have to find the general solution for sin theta equals to 0, cos theta equals to 0, tan theta equals to 0 and cot theta equals to 0. We cannot find the general solution for sec theta equals to 0 and cosec theta equals to 0.